Hey there, kiddos. Today we're going to go over the study guide for Topic 2, Unit 2, 2.1 through 2.6. Yesterday we talked about how, in preparation for the exam, you're going to want to make sure that you are completing this entire study guide. This study guide is for you. However, today I'll be going over the answers to each question in preparation for the exam. So go ahead and grab your study guide and take a look for the first question. First question asks, how would you define or what are integers and rational numbers, and how are points graphed on a coordinate plane? There could be various answers for this. In your notebooks, you should have the definition of an integer as well as the definition of a rational number. Integers are all counting numbers and their opposites. So if we think of 1, 2, 3, 4, 5, and their opposites, -1, -2, -3, -4, -5. We want to make sure that we don't forget about 0 as well. And then rational numbers are all numbers that can be written as a fraction where neither the numerator nor the denominator is equal to 0. And so -3/4 would be a rational number. Positive 17/21 would also be a positive number, a rational number, excuse me. And then also rational numbers can also be equal to decimals. And then finally, how are points graphed on a coordinate plane? If we think about a coordinate plane and think about the posters that we have in the classroom, a coordinate plane is broken up into 4 quadrants. We see that there's an ordered pair, 2 values, 2 numbers that tell us where to go on the coordinate plane. That first value, that x coordinate, lets us know where to go horizontally, left to right on the coordinate plane. And then the y value, that second number, is letting us know where to move vertically along the coordinate plane. So for example, the poster we have in the classroom of an ordered pair of -3, +8. -3 is saying, hey, if we're at the origin, 3 units to the left, and then 8 units up, will put us in quadrant number 2. And so -3, net +8 would be a point in quadrant 2. Now, as vocab review, we are asked, hey, a point on the coordinate plane is represented by what? By an ordered pair. And so we have the example that we have here of -3, -8. The second question is, the opposite of a positive integer is a negative integer. So positive integer, +2, opposite, -2. And then finally, a rational number is any number that can be written as the quotient of 2 integers. And remembering that the word quotient is indicating to us that it is the answer to a division problem. So numerator, denominator. And then our example here, -3/8. So explain how the points A, +9, -2/5, and B, +9, +2/5 are related, and use vocabulary words in your explanation. So there could be several different answers here that could vary. However, excuse me. However, one of the things I would hope that you would mention in your response is that the x coordinates are both 9, +9, so they have the same x coordinates, which means that there are 9 units to the right. So point A is in quadrant 4, and point B is in quadrant 1. Let's take a look at the second page, which is a review of lesson 2.1. In lesson 2.1, we see that we have this quick review of just what are integers. What are integers? Integers are all counting numbers in the opposites and 0. Now, don't want to forget 0. So when we take a look at question number 1, which is saying, hey, when we look at this number line, where is A indicated? Or where is A located? And then write its opposite. Well, A is located at +3, and its opposite would be -3. For number 2, letter B is located at -1. Its opposite would be +1. Number 3, letter C is located at +6. Its opposite would be -6. Letter D is located at -7 on the number line. +7 would be opposite. Letter E is located at -5. Its opposite would be +5. And letter F is located at +1. Its opposite would be -1. When we take a look at the number line for 2.2 and being able to represent rational numbers on the number line, when we look at 0 to 1, we'll notice that there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 there are 9 hash marks that divide the 0 to 1 into 10 pieces or tenths. So that means each one of these marks here, each one of these spaces between 0 and a hash mark is equal to 1/10 or 0.1. So that means when we're looking at a number line, we'll be able to determine, hey, how is this value between 0 and 1 divided? Sometimes on the coordinate plane, you've seen, kiddos, that it's divided by just 1. So 0, 1, 2, 3, 4, 5, etc. Whereas other times, they have been dividing in half. So you'd see a 0, there'd be a hash mark, and then the number 1. So because it's divided in 2, each of those hash marks is representing a half, or 0.5. So you need to look at the scale. You need to see, hey, how is this coordinate plane divided? How is this number line divided? Because it can differ, and depending on that difference, that'll indicate what each of these marks are equal to. And so when we look at question 1, where it says, hey, where's 3/4 located on the number line? 3/4 is equal to 0.75 or 75 hundredths. So when we're looking at our number line, it's going to be in between the 7/10 and the 8/10, which is located right here. So 7/10, 8/10, right in between of that would be 75 hundredths or 7.5. Number 2 is negative 2/4, or excuse me, 2/5, which is the same thing as 4/10 is the equivalent. And so when we're looking at our number line, we're going to go start at 0. Because it's negative, we're going to move to the left. And then we move 4 units to the left, will put us at negative 4/10. So negative 2/5, which is equivalent or equal to negative 4/10 by multiplying by 2 times 2, and that's how we get 4/10. So the place mark on the number line would be negative 2/5 would be here. And then 0.5 or 1/2 or 5/10, then we go 1/10, 2/10, 3/10, 4/10, 5/10 would be located here. And that's why our third point is located at that point there. Let's take a look at questions 4 through 7, where we're looking at inequalities. And when we're looking at these inequalities, we'll see that 0.25 is equal to 1/4. 25 hundredths is equal to 1/4. If we were to take that 25 hundredths, or 25 over 100, if we simplify that, 25 goes into 25 one time, 25 goes into 100 4 times. So those two quantities are equivalent. They're equal to each other. When we look at question number 5 is asking which of these is greater than, equal to, or less than. And 1 5/8 is going to be greater than 1.6 or 1 6/10, because that 5/8, if we were to divide that 5/8, and what is that equal to as a decimal? Well, 8 is our divisor, 5 is our dividend. We add a decimal, and this time we're going to need 3 zeros, as you'll see as we divide. Can we subtract 8 from 5? Nope. That'd be 0. Can we subtract 8 from 50? Yes. How many times? 6 times. That'd be equal to 48. When we subtract, regroup, this is now 10, this is 4, because it's 2, bring down the 0. How many times can we subtract 8 from 20? That'd be twice. That gives us 16. Subtract, regroup, that's 4, bring down the 0. How many times can we subtract 8 from 40? And that'd be equal to 5. And so 1 5/8 is equal to 1.625. 1.625 is greater than 1.6, so that's why we have this inequality. As a reminder, whichever direction the point is, since this is pointing to the right, this is saying, hey, this is greater than, or further to the right, than 1.6. When we look at question number 6, 3.65 is less than, it's pointing to the left, this number is found to the left of 3 3/4, because this would be equal to 3.75. And then last but not least, this is where most students will make a mistake, because they'll see 2/3 is less than, or excuse me, 2/3 is less than 3/4, and want to say, oh, because of that, that's the reason why this is less than that. The reality is, just remember, pay attention to the negative sign. The closer we are to 0, the greater that value is. So even though 2/3, which is equivalent to 0.66, and 3/4, which is equivalent to 0.75. Even though 0.66 is less than 0.75, we want to remember, because of that negative sign, negative 0.66 or negative 2/3 is greater than negative 0.75 or 3/4. Taking a look at lesson 2.3, where we are supposed to find the value of each of the absolute values. Every single value here, we're just going to want to make sure that we're paying attention to what is in between those two absolute value bars is going to be the distance from 0. So for number 1, the absolute value of negative 9 is 9. The absolute value of negative 2 is positive 2. The absolute value of positive 4 is 4. But then the opposite of the absolute value of 10 would be negative 10, because the absolute value of negative 10, is 10, but then that negative sign that's outside of the absolute value bar is telling us to take the opposite of that. Okay? And now, ordering from least to greatest, we have each of these values here. So from least to greatest, the absolute value of negative 2 would be the lowest, and then the absolute value of negative 3, followed by positive 10. And so for each of these, least, second, and then greatest, least, second, then greatest, least, second, and then greatest. All right. Now, how do we represent rational numbers on the coordinate plane? To represent rational numbers on the coordinate plane, we have the following. For letter U, because we are not moving left or right, that's the reason why our x-coordinate is going to remain 0. And because we're moving up 2.5, remember what we said earlier, take a look at from 0 to 1, how many places are there? We see that there's one space in between. So each of these are equal to half units. So this would be 2.5 units for U. V is negative 2, 1.5. So we're going negative 2 and then 1.5. W is negative 4, negative 1. X is 2.50 because, again, we're just moving to the right. On the x-axis, we're not moving up or down. So that's why that's positive 2.5 and 0. For letter Y, it's positive 2, negative 1.5. And then letter Z, negative 1.5, negative 3. And then for our 2.5 and 2.6 review, finding distance on finding distance and representing polygons on the coordinate plane, we have the following, that we're going to be just looking at this polygon, and we're being asked, hey, what is the length of each of these sides? And so the length of BC, we'll see that there are 2 units that are here, but remembering that each of these units is equal to a half, and that's why this is just equal to the distance of 1 unit. For number 2, CD is equal to 2 units. For DE, this is equal to 3 units. For EF is equal to 4 units. FA is equal to 4 units. And then the perimeter, adding all these sides together, would be equal to 16. So we have AB, which is 1, 2, 3, 4. So this is 2 units. 1 unit, 1, 2, 3, 4, 5, 6. So this is from DE is equal to 3 units. 1, 2, 3, 4, 5, 6, 7, 8. So this is 4 units. 1, 2, 3, 4, 5, 6, 7, 8. So this is equal to 4 units since each of these are equal to half units. So 2 plus 1 is 3. 3 plus 3 is equal to 6. 6 plus 4 is equal to 10, and then 10 plus 4 is equal to 14. So actually the perimeter of A, B, C, D, E, F should be 14. Or did I count wrong? 1, 2, 3, 4, 5, 6, 7, 8. Yep, that'd be 4. 1, 2, 3, 4, 5, 6, 7, 8. That'd be 4. 1, 2, 3, 4, 5, 6. Oh, that's the reason why. 1, 2, 3, 4. There's a 2 here. This is a great example of why, hey, always write your numbers down, show your work, so you can check yourself. Mr. Pierre might have made a mistake there. I thought it was 14 based off of the values that I wrote, but I forgot to add this last side, CD, which was equal to 2. And so 14 plus 2 gives us a total perimeter of equal to 16. Now for 7 and 8, we are just looking at each of these ordered pairs, QRST, QRST, QRST creates a square that is a polygon on our coordinate plane. And number 8 asks us to construct an argument to justify whether or not the polygon QRST is a square. Well, what do we know about squares? Squares are four-sided figures. They have right angles, and in particular, they have 4 right angles, which are 90 degrees. They make these corners, these vertices of 90 degrees. And we know that the thing about a square that's very special is that all 4 sides are equal. So when we look at each of these 4 sides and they're all equal to each other, that's why we can justify that this is a square, right? Excellent. And then for our last page, being able to plot ordered pairs on a coordinate plane, excuse me, each of these values here of being able to add and subtract our decimals. So our decimals from Unit 1 have not disappeared. They're still here. Rational numbers are still going to be something that will pop up and still be something that we need to be fluent with. So practicing with decimals, lining up your decimals to then add them, fractions as we've been doing for homework, reviewing of, hey, we need a common denominator when we're adding or subtraction, adding or subtracting those fractions come into play here. So each of these points here will then correspond to one of the dots that were on our coordinate plane. And then once we've labeled them, A through S, when we connect them in the order that they're here, they create a palm tree. And so what kind of tree can you carry in your hand? Ha ha ha, a palm tree. We can carry a palm tree in the palm of our hands. So, kiddos, I hope that this review in preparation for topic 2 is a benefit to you. If you review your notes, particularly your notebook, you will be very much prepared for the exam that is coming up. If you have any questions, please come to office hours, send me an email. I'll be glad to help you out. Do not procrastinate. Your procrastination will not become my emergency. Alrighty. Peace.